Welcome guys, in this video I'm going to explain the difference between a linear search and a binary search. So both of them are search algorithms for lists, and let's start with the linear search, and I'm going to explain it as we go through the example. So right here we have our main method. It has an integer array called test, and down here we have to create the function for the linear search. It's just check the given value if it exists in our list. So let's say static is going to return boolean. Let's call it linear search. Is going to take an integer array called nums as well as an integer value. So we're simply going to loop through all the elements in our array, starting from the index 0 until the last element, and then increment the I. So we just have to check if our element is equal to the value we want. We're going to return true. We're gonna keep looping until we find this value. If we reach the end of the list and didn't find it, we're going to return false. So the linear search start from the zero index, from the first element, and then check if this value is equal to the value you want. Let's say, for example, we want the number 5. It's going to check if it's equal to 5, return true. So it's not equal to 5. It's going to keep doing this for all the elements until it reaches the number 5, which is equal to the value, then return true. If the value doesn't exist in our array, it check all the elements and didn't find it, then it's going to return false. So let's call our function right here. Let's print the result. Let's call linear search. Let's give it our test array as well as, let's say, for example, the number 5. Let's run the program. It returns true because it exists. Let's say, for example, you want the number 8. Run again. It says false because it's not here. So we could do something different by, for example, finding the maximum number in our list. Let's say, for example, integer result is equal to, let's initiate it with the minimum value possible. Integer dot min minimum value. And right here, we're not going to check. We're going to check if the element is less than, is greater than our result. We're going to have to update the result. You can say result.math, math.max, the result itself, and the nums value. If it's greater than our result, it's going to update it. Then right here, we're going to return the result. And right here, let's say result. And now we don't need this value anymore. We need the test only. So it's coming right here. It should return an integer. Let's run our program. It's going to return 6 because it's the largest element. Let's say, for example, this one was 34. It's going to return 34. So this is how linear search works. It checks all the elements until it reaches the end of the array. So it's obviously the time complexity of the linear search is big O of n. Time, it's linear O of n because it checks all the elements until it reaches the end. So the good thing about the linear search, we can use it in if the array was ordered or unordered. So the order of the array doesn't matter. We can do it anyway. So now, after we finish this one, let's start doing our binary search. Let's create this function. Binary is going to return a boolean because it checks if the value exists in the array. is going to take an integer value called nums, integer array, and integer value. So the linear search works by uh, we have to store the first index and the last index. We have to find the pointer, left pointer and right pointer. This one is gonna, the left pointer is from the start and right pointer from the end. Then we have to find the middle element. Then we have to check. For example, we want the number 2 and our middle element is 4. First of all, we have to check if the middle element is equal to the number we want, which is 2, then return true. Otherwise, check if the middle is greater than the number we want, which is in this case 2. It's the number 4 is greater than 2. Then we have to remove all these elements from the array and look in this side because the number we want is less than our middle number 4. We can do that by updating the right pointer to be equal to the middle pointer minus 1. Let's do that right here. First of all, we have to create our left, which is equal to 0 always, and our right, which is equal to nums of name minus 1. And now we're going to create a loop. It's going to check if the left is less than the right, less than or equal than the right. Is going to do our code. We have to check if the left is still less than the right, because if the right become less than the left, then this is the end of our program. We didn't find the value. So let's find our mid number. It's going to be equal to the left plus right divided by 2. Then we have to check if the uh, middle number is equal to the number we want, which is the value. Let's say nums mid is equal to the value, then have to return true. Otherwise, we have to check if the middle number is greater than the number we want. Let's say, for example, we want the number 2. If the middle number is greater than 2, we have to check this side. So we're gonna change the right pointer to be equal to the middle minus 1. So if the middle number is greater than our value, we have to say right is equal to mid minus 1. Else, which means the number we want is greater than the middle, we're going to say left is equal to mid plus 1. Now, uh, let's test this binary search. Let's give it, for example, the value 2. And right here, after we finish the program, if we didn't find it, we have to return false. So let's call this binary search. I'm not sure of the spelling. And let's run. It returns true because the number 2 exists in our array. Let's say, for example, the number 8. It returns false. So when we say the number 2, it returns true because first of all, the middle number is going to be 4 because the middle number is equal to the left and right, which is 0 plus 5. It's 5 divided by 2. It's going to be 2.5, but we neglect the point, so it's going to be 2. 0, 1, 2. So the middle number is 3. Okay, so check if the value 3 is equal to our value we want, which is 2. It's not. So we're gonna check if the middle number 3 is greater than our value, true. So the right pointer is going to be equal to middle minus 1. It's going to be right here. And this one is the left value. The same, would be the same. And then we're gonna do the loop again since the left is still less than the right. then it's going to check the middle number would be 0 plus 1, it's 1, and the divided by 2, it's going to be 0. So this will be our middle number, and then check if this is equal to the 2, which is not. Is going to check if it's greater than the value, which is not. So the left will be the middle plus 1. So this one is the left is equal to the middle itself plus 1. So this one is gonna be equal to the uh, left pointer, as well as the right pointer will be here, right here. And do the while loop again, and find the middle number, which is 1 plus 1 is 2, divided by 2 is 1, and check if the middle number is equal to the value. Middle number is equal to our required value 2, so it's going to return true. If the number doesn't exist, it's going to return false. So you can see here it's much faster, because if this one was our middle and we have to find the number 5, we're going to remove all the side from the subarray and look only in this side. So it's twice faster as the linear search, because we check half of the elements. So the time complexity of this is going to be, time complexity is big O of log n. As you can see, it's much faster than the linear search. But the problem about this binary search, the array has to be sorted to perform a binary search. So if we had a sorted array, it's always better to use a binary search. Otherwise, if the array was unsorted, we could use a linear search. So that's it for today. I hope you liked it. If you did, don't forget to subscribe, like, and share, and catch me on the next one.